My brain wasn't.
Yeah, so. It was for how.
Well, he doesn't understand law.
Yeah.
Yeah. No, it's. But I definitely. Pretty much. So pretty. It's like, okay, you can try.
What? Oh, one day. Oh, so there's.
Well, I'm sorry. I mean, you like. I mean, I can use it like several. I know I go home, I was like, hey. Wait, how good? You don't. I should probably not. See.
I guess. Or how long.
Oh, Judy.
Yeah, it's for, it's for student. Yeah.
I would like.
Yeah, like, more holidays, Christmas, like. Study. Oh, it's already the whole.
Yeah.
Always. Video on it. Yeah. It's the first time Friday, December. Yeah. Okay. It's just. Yeah.
So the extra credit, that was due last night. There was not very many students who understood what they needed to do. So I want to go over it a little bit more just to make sure. For the qualitative part, and I also went and put points, so when you open up the project, there'll be one part that tells you the points for each part. And creativity is 7 points out of the 65 points. For qualitative, which is data that is non-numerical, you need a bar graph and a bar graph and a pie chart. And you need to somehow gather data. One favorite candy bar, that's not going to get you your 7 creativity points because I've used favorite candy bar 100 times. But if you did that, which is fine, you could make it creative and surprise me. But if I went around the room and asked favorite candy bar, I'm going to get a lot of different answers. More than 5 to 7. So for your outcome for qualitative, you only want 5 to 7 possibilities. And if you're getting too many, then maybe you need to make a list. For instance, favorite band. There's a lot of different bands. So maybe you pick a few of them and say, out of these, what's your favorite band? If you don't want to ask people, you can make a survey online. Or you can do research. You can look at the first 25 sharks that were spotted during Shark Week. What type were they? These are going to keep repeating. Like maybe there was 10 whale sharks. There was 5 great white. There was so many hammerhead. And so you can keep track of that. You want to get 5 to 7 answers though. You don't want to say, do you like listening to music? That's a yes or a no. So then think of it, you're going to have 2 bars. One's going to be higher than the other one, or maybe they'll be equal, and then your pie could be cut right in half. So you need more than 2 outcomes. You want 5 to 7. If you're getting way too many, make it multiple choice. If you're only getting 2, think of something else. Any questions on qualitative? Another one in my one class, we were talking about like looking at 25 different states, or not states, but colleges. You could see what the top degree is. For instance, at YSU, I mean, there's a lot of large ones now, but business, engineering, education, and healthcare, those are 3 huge ones. Criminal justice is becoming very large now too. But you can find out which one of those has the most students in it. Look at 25 different colleges. And that would be your data. Any questions on that? I don't think there's 25 different majors, but you could grab less colleges. Look how many for each major. If there's 25 different majors at YSU, depending on, like, instead of business school, if you went with accounting, management, all of them, you probably could get 25. And how many students are in each? That would be interesting. So your outcome would be the different things like mathematics, statistics, data analysis, all of those different ones, that's qualitative. Any questions on that? Quantitative is a number. No, it's not how many sharks. The sharks were still the quality because it was the type of shark. But population would work. One student put the population of Ohio, but that's only one. You still need 24 more. So you could find the population for 25 states. You can find the population from 25 countries. If you don't want to do a questionnaire, for instance, ask 25 people their age, you don't have to. Mileage of someone was doing the mileage of their car. But if you don't keep track of your car, say monthly or weekly or yearly, then you can't really show the car because you need 25 pieces of data. For my husband, every time he fills up my gas tank, he writes the mileage so he can keep track of miles per gallon and make sure they're close. So I could easily, the last 25 times I filled up my gas tank, get 25 different mileages. But that's not necessarily the case, so then you need 25 different cars. Any questions on quantitative? So whatever your number is, then you're gonna get it from 25 similar sources. 25 colleges, 25 students, 25 countries, 25 basketball players' heights. Any questions on that?
So for the qualitative, so you did the ones with the bands. If you did like, you have to have like 25 different bands or have like 25 different people answer. Because you did Jonas Brothers, BTS,
Yep.
whatever.
You want 5 to 7 bands,
Okay,
25 people.
okay. Thank you.
Yep. And then on this one, you could do 25 different bands, how many concerts they did in a year or how much they made, but here you would do 25 different bands, where the other one, you want 5 to 7, 25 people. Any other questions? I know that at least 12 people, not all from this class, used ChatGPT because they all had the same answer. And the thing is, it's not correct. So if we go, you can click on here and go to it. You'll have to log in. It's free if you haven't used it before. But it's an AI and it will, yes, do your tests for you. But they're not usually right. So don't use mine because they won't work out. The one time I tried to do the humanization project in here and he said, I can give you some ideas, but I don't know how to solve that or something like that. So I was kind of glad about that. But anyways, you could put list of 25 qualitative data. Same one I got earlier today. This is all ideas. Pick one of them. You don't want to do all 25 of these because then you'd have to find 25 of each of them. So these are great ideas. Some of them are ones like if you looked at the first one, whoops, color, asking 25 people their favorite color. One thing I had one time, student went on the bridge at Wick and kept track of the first 25 cars that went by and marked down what color the car was. I don't know that you could get a quantitative data from that, but you can get qualitative. And then you can ask 25 people the miles of on their car, how old their car is, things like that. Gender, male, female, non-binary. You want to kind of get 5 answers, so I don't know about that one. Marital status, married, single, divorced, widow, widower. So these give you ideas. Occupation, you could end up with a ton of different answers though, but maybe you narrow them down somehow. Movie genre, comedy, drama, horror, musical, type of car. So these are all great ideas, but only one of them, not all of these. Any questions on that? Oh, taste preference. Sweet, salty, spicy, sour. That's kind of different. Any questions? This might be interesting. Housing, apartment, house, condo, dorm. See how many people commute or where they live. That's kind of interesting. Any questions? So then this was qualitative. You can do the same thing for quantitative. Qualitative. Oh, those all say qualitative. Oh, I spelled something wrong. No, maybe not. Age, height, weight, income, temperature. Now, temperature is one where you wouldn't have to ask people. You could do the temperature for the past 25 days. You could do the temperature for different states in the United States on one day to see how it ranges. You could do different countries, 25 different countries, and see how the temperature on one day fluctuates in different areas. I think that's kind of interesting. The number of children in a family. So there's a lot of different examples. And then whatever your major is, you could say qualitative data in art, qualitative data in accounting, and it will give you things. Now, some of those sometimes get a little more difficult, so be careful with that. But any questions? So those who found this on here, which is fine, you only want one, not all of them. Any questions? Yes.
Does our qualitative data have to relate to our quantitative data?
No. So the two don't have to go together. Sometimes it's nice when you're making a project if they do go together, but they don't have to. Another thing, Friday's a group assignment, but if you want to make a questionnaire and we can just pass it around the class and they can answer it for you. So this Friday, if your qualitative or quantitative data is something asking students, then we can just pass it around, they can answer it for you, and today there's not 25, but there's supposed to be 40 people in this class. Or maybe not 40. This one's a little small. Okay, 38, I was close. There's supposed to be 38 people here. And usually group assignments, there's a lot more. So you probably will get your 25 just from this class. So just take a sheet of paper, ask your question, whatever, multiple choice. I recommend like 5 to 7 pick from for qualitative, depending on your question. And we'll just pass it around. Any questions on that? Okay. You will need this Desmos open for the second part, but I'll do the CoRec first. Now, last week, I forget which day, but I showed you a little bit of what a scatter plot looks like. And these are examples of scatter plots. This one is a very strong relationship. It's real close to a linear line. This one is also increasing, but it's more spread out. It's not as strong. This one is more exponential than a straight line. So it's not really linear. But we can still find a linear line. It just won't be as strong as an exponential would be. This one's spread out all over the place. You can't tell if it's increasing or decreasing. So they call that no correlation. This one is a negative correlation. It's going down. It's not as strong as this one or this one, but there is still a relationship there. This one is going down except for these two here. Whenever that happens in a scatter plot, check and make sure you entered it correctly. But if you did enter it correctly, those are outliers. And a lot of times a statistician will take those out. Any questions? We're gonna try this activity. My daughter was teaching scatter plots for her student teaching, and then she found this, so she took my notes, I took hers. You want to go to this website and you'll log in. Right now it'll have it on pause, but you'll log in to get into my class. Now if you click onto this, it'll go right to my class. Just put your first name. You don't have to put, unless you've already been in it, then you would, it'll just have it. So when you come in, then I will just approve you. It's showing a scatter plot, and I think I have it on pause. Yeah. But go ahead and get on, and then I will let you in. Right now, there's a couple people. Two, only two. Why that's highlighting everything. There's got to be a way to just let everyone in. But... Okay, so the first one, you want to draw a line. This red line, you want to move it. So you can grab the point and move it. And you want to try and get it between all the lines. Those who are online can also get on. Bless you. This one we can tell is going down. About like that. But you want to try to get it to go through the middle of all the points. So there's some on each side if necessary. And it goes right down. And this shows you the students who have done it already. So you want to move your dots so they're in between. Any questions on it? So these are different classmates, what they got. And then we could make them overlay each other. So this one pretty good. This one, they're a little more spread, but this still. Any questions on the first one? Oops. So the third one. Again, you want to try and get it. Now what they're showing these lines for is right now I'm on this axis. I want to try and get this red arrow to green. So then as you move it, type in what you noticed. So drag the red points, try and make your line as precise in the green as possible. Describe how you got the higher values on the meter. And then just hit share. I got the highest score on the meter by adjusting the line unit. Very good. Putting the line as centered to the middle as possible. Meter goes green when you get the red light line in between all the blue dots. So you want to get it as close to the middle as possible. And you can see, any questions on that? So go ahead and try the next. So this one wants you to first put the line and then see how accurate you are. Not bad. Any questions on it? So that line, you want it to try and get as close to running between your data as possible. And normally what you would do in an algebra class, you'd pick 2 points and then use them to find the equation of the line. For our class, Desmos is going to do that for us. Okay, so the last one, you want to click on here and make a challenge with at least 5 points. Click next and it'll be up there for students to try. And so then you can put a couple challenges for your classmates and they'll try it. Any questions though? So you can kind of see what your project's probably going to be the next one, where you'll get 2 numerical data and see if there's a relationship between them. Any questions? Oh, I thought it would let me. I gotta go under student. So this one's a positive relationship. Any questions? Okay. I think it kind of gets you the idea of the scatter plot and the line going between them to try and make an estimate. Because then you use that estimate for your data. Okay. You will want to open the chapter 8 outline on Desmos. That's where we'll get our data to graph with. And here it is. Chapter 8 outline. So we're seeing the relationship between two values, and that's why those were points. They were X and Y, graphing on a Cartesian system. So it's called a scatter plot. And it's the graph that represents a relationship between two variables which are quantitative or numerical. It's a two-dimensional plane or a Cartesian system. It's just the XY axis. The independent variable is the x-axis, and the dependent variable is the y. Now, sometimes there's definitely an independent and a dependent. For instance, the height of waves and the number of surfers. The higher the waves, the more surfers. So the height of the wave causes how many people are going to be at the beach. And so independent would be the height of the wave, the x-axis, and then the number of surfers would be the y-axis. Because the number of surfers doesn't cause the waves to be higher, but the higher waves causes more surfers. And that's how you decide independent and dependent, which one causes the other. But some cases, the length of your arm and your height doesn't matter which one, because the length of the arm doesn't cause you to be taller, and being taller doesn't cause the length of the arm. They just have a relationship. In that case, you could go either way. Now, we've looked at a lot of images of scatter plots already on Desmos, but this one, these two are both increasing, and they're pretty strong, other than this one here, outlier. But both of them are a positive linear relationship. This one, they say it's strong. This one, they're saying it's not as strong because of this one point out here. The last one is still a strong relationship, but it's going down. So increasing or decreasing, you look at your line from left to right. So this one's going up, and this one's coming down. And that's why it's a negative relationship. The bottom row, this one, again, we've seen this on Desmos. This is kind of going down, but it's not as strong. It's a weaker relationship. It's spread out a lot more than the last one on top. This one is more an exponential growth than a line, but we could make a line go through there. So we could get a linear estimate, just won't be as accurate. This one, they're spread out all over the place. Usually when this happens, your line will go horizontal. Any questions so far? So the line we were drawing earlier, it's called the linear regression line, or trend line, or line of best fit. All three, same thing. It's used to estimate a relationship between two quantitative variables, two numbers. Explain how strong the relationship is between the two variables and the value of the dependent of a certain value of the independent. So how does the independent cause the dependent to change? We're just looking at linear. You could do quadratic, exponential, but for our class, it's pretty much just linear. Now we keep talking about how strong the relationship is, and we know when the points are very close to the line, it's strong. Well, we gave it a name, it's correlation, and the number is R. Now, if you use Excel to graph, it's going to give you R squared. You have to take the square root to get R. Desmos gives both. A scatter plot and explains its correlation. It tells you how strong or close to the line it is. A positive correlation, so if R is positive, we know as X increases, Y increases. Just like when we explain the slope, X is always increasing and then Y either increases or decreases. So if we have a negative correlation, X increases, which causes Y to decrease. If the points are all over, there's no correlation. In the next slide, we'll see numerical wise, but is there any questions? The values of R are between -1 and 1. The closer it is to -1, the stronger the negative relationship. So negative is just telling you negative relationship. Positive is telling you positive relationship. If it's close to 1 or -1, it's very strong. If it's close to 0, no relationship. But how close? Your book says a half. So if it's between -0.5 and 0.5, that's weak. Anything outside of that, so greater than 0.5 to 1, greater than -0.5 to -1, would be strong. Or close to 0.5 is a weaker relationship, but there's still a relationship. So the closer to 1 and -1, the stronger it is. Once you hit that -0.5 to 0.5 range, there's not a relationship. And 0, there's no relationship, just spread out all over. I should have drew one of those when we were doing that. I didn't think of that. But any questions? This kind of shows you though. So it's showing you the R value, the trend line, and what the data will resemble. Notice the first one, R equals 1. When R equals 1, you have an exact, or they call it a perfect relationship, because all the points are on the line. That trend line gives you exact answers. All the points are on the line. So on your next exam, if I say, what can you say about the points and the trend line when R is 1? Well, all the points are on the line and the line is increasing. Or if I say -1, all the points are on the line and the line is decreasing. You'll definitely see that on the test. Notice as we go across 0.8, there's still a strong relationship, but it's spread out more. But it's positive, it's going up. And get closer to 0, 0.3, notice the data spreads out a lot more. There's not as much of a relationship. We can see this one's kind of growing, but it's spread out, so it's not going to be a very accurate estimate. And then 0, just everywhere. So you kind of get that horizontal line when it's 0. Notice as we're going this way, the graphs are similar, only decreasing. -0.3, bless you. It's spread out a lot, but it is decreasing. This one, it's very close. But then when we hit -1, all the points are on the line. It's an exact relationship. Any questions? Describe the relationship you would expect between the data. So is it positive, negative, or no correlation? The age of an automobile and its odometer reading. So as the age of an automobile increases, what happens to the mileage? Increase or decrease? The more you have your car, what's your mileage do? It increases. So that is a positive relationship. As the age increases, mileage increases, positive relationship. The amount of time spent fishing and the amount of bait in a bucket. Amount of time spent fishing increases, what happens to the bait in your bucket?
It goes down.
It goes down, yeah. Because we keep putting it on our hook, and so it is negative relationship, it goes down. How about the number of passengers in the car and the number of lights on your route? Yeah. There's no relationship. Doesn't matter how many people are in the car, you're still gonna have the same number of lights on that route. So there's no relationship. Any questions? Scatterplot shows the number of lawns mowed by a local lawn care business during 1 week. Describe the relationship shown by the data. So notice our x-axis is days worked, and going up the y is lawns mowed. So as the number of days they work increases, what happens to the number of lawns mowed? It also increases because it's going up from left to right. So that would be a positive relationship. Does it look like it's strong or weak? It looks like it's forming a line. It's a pretty strong relationship. So there's a strong positive relationship. As days worked increase, lawns mowed increase. And I think I put trend line. Any questions? Okay, so you do want to have Desmos open and either Excel, and then you can copy and paste, or you'll have to type them in yourself. It's up to you. So they will not copy and paste from here. I could not find any way to get it to work. So what this is the table shows the number of students remaining on an after-school bus and the number of minutes since it left the school. So we want to get that back. Go to Excel, and this first one here on the top left, you want to highlight just the numbers. Excel Desmos doesn't like words. No, that 0 is highlighted. It's just giving me a starting point. Control C, and you can see it around the whole thing. So you want to copy it and then go to desmos.com. And use graphing calculator. And we did a little bit of these one day last week. Control V, and it zoomed it for me. If it didn't, there'll be a little magnifying glass, and you just click on it here. Everyone getting the graph? Well, the point. So these were the different times. This is when the school bus left, and this is how many people were on the bus. And what it did was it plotted the points. It went over 5 and up 45. So over 5, up 45. Over 9, up 39. It plotted all those points. Now, to find a line, remember a line is y equals mx plus b. So you want to type. You also want to look up here. Mine is y1 and x1. Okay. Here it is. So I will use y1 mx1 plus b. Now instead of an equal, you use this squiggly line for approximately, and it is to the left of your number 1 key. So you want to click here, y1, and it will automatically go down. You don't have to subscript. And then you need to hit shift and the key next to your 1. mx1 plus b. Now, if you already had one there, it might give you x2 and y2. So then you just change these to 2's. But your line should be here. Notice here it tells you your slope, your y-intercept, and r. R is a negative 0.9924, which means R is strong negative relationship. Slope and the y-intercept. I rounded 2 decimal places when I wrote it into my equation. But is everyone getting negative 1.75 and the y-intercept 54.23? Any questions? Okay. So that should be your trend line. Explaining the slope, the y-intercept, just like we did the electric bill. The x value goes up by 1, and then the y value goes up or down depending on the slope. So our x value is minutes since the bus left. Each additional minute after the bus leaves the school, there's a decrease in approximately 2 students. So approximately 2 students per minute get off the bus. So the number of students on the bus decreases by approximately 2 each minute. Any question? Y-intercept. The y-intercept is when x is what value? Anyone? The y-intercept is when x is 0. X is the minutes since the bus left. So at time 0, that means the bus is just leaving. It hasn't even been gone a minute yet. So when the bus is just leaving, according to the y-intercept, there's approximately 54 students on the bus. If you look at the table at time 0, there's 56 students on the bus. That shows you the trend line is not exact. It's an estimate. Still pretty close, but it is an estimate. When the bus leaves the school, there's approximately 54 students on it. So it is just an estimate. Any questions on that? We did already talk about the R is negative 0.9924. The negative means it's a negative relationship. 0.99 is very close to 1. That means it's strong. So the closer to 0, the weaker. It's close to 1, it's strong. So there's a strong negative relationship. Any questions on that? How many students are left on the bus after 10 minutes using the regression line? The regression line is the line we found at the beginning right up here. Are we going to plug the 10 in for X or for Y? When you're not sure, this says 10 minutes. So then we go over here and notice minutes is X, students is Y. So we're plugging it in for X. When you plug it in for X, are you getting 36.73? Approximately 37 students are still on the bus after 10 minutes. And this is definitely things they use. They figure out approximately how many students are on a bus at certain times. So then, say after 10 minutes that bus got into an accident. Well, they know there's approximately 37 students on it. Could be a little more, could be a little bit less, depending on someone being absent, someone is going with somebody else home. But they know that they're talking about approximately 37 students. So they use these estimates for a lot of different things, and this would be one example. Any questions on it? And the next one, the table shows the number of losses a gamer has X weeks after getting a game. Well, if you think about each week that you have a game, are your number of losses going to go up or down? The losses. Hopefully, the longer you have your game, you have less losses. Your wins are going up, but the losses are going down. Well, unless you're keeping total. But yeah, no, that's okay. But hopefully they're going down, depending on the person. But this would be each additional week, the losses are going down, and hopefully it's a negative relationship. So you want to go to Excel and copy this one, weeks and losses, not the words, just the numbers. Okay. Control C to copy. Go to Desmos. Delete what was there. And then Control V. Now, if you didn't delete what was there, it will put X2 and Y2 instead of X1 and Y1. And just make sure then for your equation, you make these twos. It doesn't like when you use the same equation, you have to just delete. Now notice how close these are. It looks like a nice straight line. And if I click here, it still is. But it zooms it for you. Now the next one, when we zoom, it's gonna look different. Find the line, Y1, and the little approximate MX1 plus B. There we go. Negative relationship. R is a negative. They look very close to the line, which R is 0.9961, very close. So there's a strong negative relationship. To find the equation, are you getting M, which is the slope, negative 2.28571? And then B, which is your y-intercept, 16.8571? I'm going to round 2 decimal places. Is everyone getting the lines? Any questions? Okay, so back here, and there's my trend line, or my line of best fit. Explain the slope. And this one we already said. So for the slope, we're talking about X increasing by 1. Each additional week that he owns the game, the number of losses decreases, because it's negative, by 2. Each additional week of playing the game, the number of losses decreases by approximately 2. And you can round to an integer, especially when it's a game. You're not going to have part of a game. Well, if we were talking about the amount of grain left in a silo, then that could be decimals. But people, games, usually we round to an integer. Any questions on that? I also opened this one, if you didn't notice, but we know it's a strong negative relationship because it's R is negative and it's close to 1. Any questions?
I thought it was just like 5 or something.
Using the regression line, how many weeks is it till the gamer has only 4 losses? Are we gonna plug that 4 in for X or for Y? Mm-hmm. Y is the number of losses, so we plug the 4 in for Y. So go ahead and plug it in and solve. So when we solve this, we want to get X by itself. How do we get rid of the 16? Anyone?
Subtract it.
Mm-hmm. Because it's being added, to get rid of it, you subtract it from each side. So then you get a negative 12.86 equals a negative 2.29x. We want to get the X by itself. How do we get rid of the 2.29? Anyone?
Divide it.
Mm-hmm. Divide it. A negative divided by a negative gives us a positive 5.6. I didn't write a complete sentence, but approximately 5.5 weeks until the gamer has only 4 losses. Any questions on that? Let's try this one. Now this one, it's years since 2000. So then in 2001, that would be a 1 because it's 1 year after 2000. And where X is 5, that's 2005. It's 5 years after 2000. So we went up to 2008. A lot of times when you have those years, then they have a starting point whenever they started the research. Rather than having 2000, 2001, 2002, and so on. They just do years after. So we want to go to Excel, highlight the data, and put it in Desmos. Control C to copy, Control V to paste. And clear my other 2. Now, if you look at my drawing, it kind of looks like a snake. It looks pretty horizontal. But then if you zoom it and have it fit, it actually shows you better the relationship between the points. And you do that by hitting the magnifying glass. Notice it is definitely a positive relationship where I couldn't see that before. It's all in how they put the units. But you can see then the line should fall between here. I'm on X1 and Y1 again. So Y1 is approximately MX1 plus B. There's my line. R is 0.7372, so positive relationship, not as strong as the other ones we've seen, but it's still a strong relationship. It's just weaker than the last two, but 0.7 is still strong. There's definitely a relationship. The y-intercept and the slope. The slope is 0.19, the y-intercept 5.36. Is that what everyone's getting? Any questions? Positive. So I'm going to take the slope and the y-intercept and write them into an equation. So y equals 0.19x, that was our m, plus 5.36, that was our y-intercept, or b. Any questions on that? Go ahead and interpret the slope and the y-intercept. For the slope, it's a positive 0.19, and we're talking about years and I believe it's mortgage rate. Yeah, mortgage interest rates. Interpreting the slope, x goes by 1. So each additional year, the mortgage interest rate increases because it's a positive slope. It increases by 0.19%. Because y is in percents. So it's increasing approximately 0.2%. The y-intercept is when x is 0. Well, and x is 0, it's the year 2000. That was our starting point, 0 years from 2000. So in 2000, the interest rate was approximately 5.36. Using our trend line, it was 5.36. Now, if we look at what the actual was, it was 5.5. Yeah, our trend line is not exact. In fact, R is only 0.7. But it's not too far off. 5.5 and 5.36. Any questions on the slope and the y-intercept? Somewhere on the in-person exam, probably the electric bill, you will need to explain slope and y-intercept. And on the last project. Use the equation to predict the mortgage interest rate for 2010. So if we want to figure out the rate for 2010, are we going to plug into X or Y? If we want to find 2010 in this equation, am I going to plug in X or Y? Look on the table and see where it falls. Is years X or Y?
Thanks.
So I have to plug it in for X. And then if I look at it, it's years since 2000. So am I putting 2010 in or am I putting something else in? Look at the X values. 0, 1, 2, 3, 4, 5. So what should I plug in for X? 10. What you do is it's years since 2000. You could take 2010 and subtract 2000 and you plug a 10 in. So we have plugged 10 in for X. You're getting 7.26. So the interest rate in 2010 was 7.26%. Approximately, because we're using the trend line, which is an estimate. Any questions on that? Now, the next part that there's definitions for is extrapolation and interpolation. That 2010 was outside the range of values that was tested. We went from 2000 and 2008. 2010 is outside of that, so that's an extrapolation. We don't know if rates kept going like that. COVID could have happened and everything could have dropped. And then everything went sky high again. So it's not necessarily tested outside of this range, but you can still get an estimate. It may not be as accurate. And so that's why there's what's called interpolation and extrapolation. Interpolation refers to predicting values that are inside the range of values that was used. Extrapolation is predicting values that were outside the range. It's not going to be as precise. One example, a student did a project on the age of the cows and the amount of milk that they produce. Well, when a cow is young, the older it gets, the more milk it produces. But after a certain point, it's only going to produce so much, and then it stays steady, and then it gets too old and it starts dropping. So if I only stay in that first range, then my line's not accurate after that. And that would be extrapolation when it's outside your range of values. This is a good picture for it. Where the dotted lines are, this was the lowest X value. This was the highest X value. If I stay within those X values, I will get a good estimate, and that's interpolation. Going outside, whether it's above or below, that's extrapolation. Those values were not tested. We don't know if it has that same value or estimate. You still can use it, it's just not as strong. Any questions on that? So when on your last project, when the scatter plot is done, when you're responding to students, you're going to have to do one interpolation from their data and one extrapolation from their data. If we look at, I brought this example back. If we do 2005, that's an interpolation because 2005 is in between here. Actually, it's right here. So 2005 would be in our estimate. This would be an interpolation. Go ahead and find the rate in 2005. Are you getting 6.31%? when we're plugging into X because that's years since 2000, and we're plugging in a 5 because we want 2005 is 5 years since 2000. So in 2005, the interest rate was approximately 6.31%. Any questions on that? And that was an interpolation because it went in between the values we used. This last one, 2012, is an extrapolation because what's our X value? In 2012, what would X be? Well, 12 is outside of this range. It's greater than 8. We've only tested between 0 and 8. So that's an extrapolation. You can go ahead and find it. We're plugging in 12 because it's 12 years since 2012. We're getting 7.64. Any question? No?
So extrapolation, the easiest way to remember that would be beyond like the extension of X, like if it's not on the table, then it'll be extrapolation.
Enter is inside your group. Yeah. Extrapolation is
So like-
outside or outside.
So it's like I was,
Outside would be extrapolation. Any other questions? Okay. If you have any questions on the project, I want to stop recording.